Thank you. All right. As I said, this is applying object-oriented design principles to the web. Now, this presentation is going to go quite fast. It is unfortunate. There's going to be a lot of information. That's just the nature of the time, but it's the most condensed down version it can be. It is being recorded, so if there's anything you get stuck on, you can always go back and look at it. So with that, we'll just jump straight in. Single responsibility principle, what is it? It states in object orientation sense that a class should only have one reason to change. Now, the name of this principle often gets people misinterpreted. They see the word single responsibility, and they think it is that a class should only have one function. That is not what it is. For example, you may have a credit card class where you have a single attempt payment function and you put all your functionality into that one function. A class is really a group of functions that are related to each other. So a better example of a credit card class would be all the functions split out. So we would have an is valid check, maybe some sort of pre-authorization checks, and the actual attempt payment. So if a class is just a group of functions that are all related together, is the following statement true? Is O of F the same as F of O? What does that mean? In O of F, we could create a new object that is a credit card, and we call the is valid function on that object. So you can see down there, card is valid. Is this the same as a is valid function that takes in a credit card object that's created using the same information? Yes, in the sense of using these functions, it's the same result. However, there's a slight difference, and quite a big one, that O of F has the potential to be anything. What does this mean? So sometimes we use abstractions in object orientation to abstract away details. So for instance, we could have a payment abstraction that has the is valid function on it, and our credit card will implement that. But when we go to actually use the payment, we don't know what the underlying class is. We just know that there is an invalid or is valid function on that. So it could be a credit card, debit card, gift card, or any kind of payment that we implement. And another difference that people often say that object orientation has to maybe functional programming is that classes have mutable state. This is true, but we have learned that this is actually bad. So we try to make our classes immutable. All right, back to single responsibility after that deviation. So we said that a class should only have one reason to change. That might be a bit confusing if you still don't get that. But what if we said that a class should only have one actor responsible for changing it? So here's a famous example of an employee class that has calculate pay, generate a time card report, and save. And all the underlying functionality for those functions are inside the employee class. So things like connecting to the database for the save method, or the reporting formatting, or the formulas for calculating the pay. What are the actors? Well, first is the accounting actor who wants to change the formulas for calculating the employee pay. There is the human resources actor that wants to change the formatting of the report. And there is the assistant administrator who wants to change how the employee is saved. So multiple actors want to change the functionality in this one class. So we're talking about the web here. We're not in the web. Generally, we don't really use objects. You might use more functions. And for this example, we're going to use React. So here's a pretty typical React component that might look like the React components that you build, and you might think, oh, there's nothing wrong with that. But we are talking about the single responsibility here. So how does this come into play? So we said a class should only have one actor who wants to change it, but we're not working with a class. But what is a class often stored in? A source file. So we could say a source file has one actor that wants to change it. So if we go back to our React component, who are the actors that want to change this React component? Well, there's always one, the developer, who wants to change how the data is fetched and the format the data is fetched in. There is the designer that is concerned about the CSS and the CSS classes and so on. There is the copywriter who's concerned about the text within the component and what is displayed. And finally, there is the product who is concerned about the behavior of the component. So multiple actors want to change the functionality in this one source file. So why is this not obvious, or maybe you still don't get it? That is because often we play the role of the multiple actors. So we as developers might be the ones who take the designs from the designers and implement the CSS classes. Or if you're a really small team or you're running your own startup, you might be the person who is playing the developer, designer, copyright, and the product. So how would we solve this? Well, one of the ways to solve this in object orientation is the facade pattern. So we go back to our employee example, we can turn that into a facade. So all the underlying functionality of those functions now been moved to classes where they are more better suited for the concerns. So anything to do with calculating the pay is now in an employee pay calculator. Anything to do with formatting the report is in our report generator, and so on. But we are talking about a React component here. So how could we do that? We could turn it into a facade. So here's our React component again, and we can start breaking it down. So those developer concerns, we could put it in a controller file. So all the other functions related to anything fetching data can go there. For designer concerns, we could do a little trick here where we can extract out the CSS concerns or anything to do with design into reusable generic components. So it removes that information from our facade. For the copywriter, we could use a template to move out those strings. And for the product, we can create a policy file where we remove out any behavior relating to the component. So here's before and after. The structure looks pretty similar, but all the concerns have been moved. So now when people want to change their own concerns, they just have to change the files that they are concerned to. And the single responsibility doesn't stop at the file level. So here is a pretty typical folder structure for a React application. This might be a structure you use yourself. However, what is the problem? What does the application do? Who are the actors? There is a concept in architecture called screaming architecture that says you should declare your intention of the application to the world and should show off who the actors are. So instead of this typical React folder structure, we should instead organize by our actors and domains. So here you can see there's an admin actor involved. There's a profile, so there must be a user. There's some sort of purchasing going on, so there's payment actors involved. And of course, we need some sort of shared functionality between these components or domains, so we can stick them in a shared folder to declare to the world that here's some things that are shared. All right, that was single responsibility. Let's go to open closed. So open closed is a class should be open for extension, but closed for modification. Now, again, we're not working with classes, we're working with functions. So we might have a root guard in our React application that determines if we can navigate to a protected root or not. And if not, we navigate to the login. So what that might look like is maybe there's some different use cases for applications. There's different companies that want to use our software. So inside the function for determining a valid session, we figure out which company it is, and then we return their own way of determining the session. So what's the problem with this? It is open for modification, but closed for extension. It is the exact opposite of what we want. Why is it open for modification? Every time there's a new use case for our application, we have to modify this function, and in turn, the root guard itself knows about that modification. So what's a better way to do this? Well, in object orientation, for example, we can depend upon abstractions. Remember the abstraction concept we talked about before? So now we have an abstracted authenticator that has the method in it, and our root guard ticks in the abstracted authenticator. So it doesn't know what kind of authenticator it is, it just knows there's a contract to work out the valid session, and it uses that. And then at our React main application level, we can swap in and out who is the use case for our application. So essentially, we are deploying a new version of the app for each use case. And this is what it looks like when you draw on a diagram. So you can see the authenticator root guard now depends on authenticator, and it doesn't know what kind of authenticator it is. And this is quite a useful concept because there is a theory that you should be able to draw a line between your dependencies and create a left and right architectural boundaries. So the right side should be components or code that is extensible and should not know who is using it. And the left side is where we isolate our modification. Open close principle states that we should be closed for modification, but we still have to modify it somewhere. We still have to deploy those versions of the application. So we isolate it to a little part of our application. But we are using functions or functional programming, and we don't have interfaces. That's not exactly true because everything is an interface. Any code you write is an interface into the real world. So how do we solve it? The exact same way as we did with the object orientation way, except for instead of a abstracted object, we have an abstracted function. So here in our authenticator root guard, we're passing in a function that we don't know what it is, and it's at the app level that we determine which function to pass in. So it's up to the application root guard to use this callback and call it when it is ready. Okay, interface segregation principle. It states that an interface should only depend on what it needs. So in example, in object orientation, we have an authenticator, keeping on authenticator topic, and we might implement a Google authenticator. So it's a single sign-on, so we don't really need an email and password for logging in. However, we get a new use case for our application. That's what software is all about, is extending it. So now somebody wants to log in on our application using an email and password. So you might update the original authenticator with still the original login method because you don't want to break the existing code. However, this causes a problem because you have to implement all the methods of an interface. So you think to yourself, how can I solve this? And you're like, I'll just throw an error to make sure nobody should be calling this. I'm a genius. However, what's the problem with this? Somewhere, someone might call that method because they're going to be using the base types. They don't know what the underlying implementation of that authenticator is. So things will go wrong. And this is a very subtle bug that can stick around for ages and you might not actually know. Maybe you've used the library before with some sort of interfaces or whatever, and you've encountered an issue. This probably was it. So how do we solve this? We split out the interface. So now we have a base authenticator where all the common functionality for every authenticator is stored. And then we can build out our individual use cases. So we have a single sign-on authenticator with a parameterless login. And we have our custom login authenticator with our login with the email and password. And then here we can see how this is made up. So we can implement as many interfaces as we want. So we can chain on as many as you want. So now you can build up the use cases individually. So the custom authenticator implements the authenticator and the custom login authenticator. And the Google one implements the authenticator and the single sign-on authenticator. And it doesn't cause any issues because you can access either of those chained on types. All right, but we're talking about the web and so on. So how would you maybe come across this problem? So imagine you had an accordion component that you made. It was shared across your team, your company, whatever. And typically people give things for their components to build. You might not see the problem yet. So then you start extending this functionality of the components. Someone's like, can you build me a left menu of this accordion? You say, yep, no problem. Someone's like, oh, if you have a left menu, can I have a right menu? Yep, no problem. And you think to yourself, what happens if someone tries to do a left and right menu? And you're like, how can I solve this? I'll do numerator values. There's only a limited set of values. I'm a genius. So you might have fixed this problem for now, but you might not realize the underlying deeper problem. And that might not come to fruition until you start building more and more properties for your shared component. So we're using TypeScript here just to make it a bit more visible. So TypeScript does give us the opportunity for some static analysis. However, if you don't know what you're looking for, you're still not going to see the problem, obviously. But you can see here, there are a lot of optional properties for our component. So something is going wrong. Not every user of the component needs these. That's pretty similar to our example in the interface and the object orientation example. So we saw in object orientation, an interface should only depend on what it needs. But we could just whittle that down to only depend on what you need. So how would you fix this in our React example? Well, you just give the people what they need and you split it out. So pretty similar how we split out the interface into the different use cases. We just split out our accordion into the different use cases and let people build it how they want. Yes, it is more code, but it is better for long-term support for our shared accordion. So people can build the top accordion menu, left, right, whatever. They can add their own icons, they can add their own functionality. All right, to wrap up, so that was a single responsibility, open closed, interface segregation. So if you're a bit clued in or you're a bit experienced, you might recognize these as part of the solid principles. So here are the solid principles. So we didn't touch on the list-off substitution, which I would have loved to, especially in a dynamically typed language like JavaScript. It most definitely applies, and actually you should spend some time looking at this because you can learn some really good things about dynamic types and static types you probably didn't realize before. And dependency version, we kind of looked at that and how to solve the open close problem, but it goes deeper than that. There are other principles. They're not really mentioned as much because they're to do with more higher level, like deploying and that kind of stuff. But we did touch on it on the folder structure of our React application. But these are the most famous examples of solid principles because they are to do with the most with the low level details of the code. And you've probably heard about them before. They're often associated with Robert Martin or Uncle Bob. He wrote about these principles back in the year 2000 in this paper. However, he did not invent them. He didn't invent the acronym. Somebody, he wrote this paper, and 4 years later, somebody says, hey, if you reorder some of these principles, it spells solid. So he didn't invent them. They've been around for quite a while, as long as the web. Dependency version, I think, was like 50s, 60s. Open closed was the 80s. List-off substitution principle was the 80s. Oh, sorry. So if they've been around as long as the web and for so long, why have I never heard about them, or why did my team not use them, and so on? So there might be a couple of reasons for this. First off, the web has a lot of influx of new developers, and what is one thing that's hard to teach the new developers? Code problems, because you can only really appreciate the solutions if you've been through the troubles yourself. And probably the more likely reason is these are often phrased as object orientation principles. So on the web, we don't do object orientation, but we learned that's kind of not true. So people might limit themselves saying, I don't do object orientation programming, so they aren't really relevant to me. What are these design principles really about? It's about organization. And what happens if you don't really care about organization of your code? Well, if you've ever worked on a new project, you've probably experienced this before. Things are really fast, you're getting features out, everything's going great. And then as things go on in time, it might get a bit harder to extend that code because it's got underlying issues. Maybe it might not be obvious, maybe you do know about them, you just don't have time right now. And eventually, as time goes on, things start to dip down, and you reach a point where it's very hard to add even the simplest feature. What happens if you do care about the organization at the start? Well, it takes a bit more time because you're writing some more extra code, you're thinking about things more carefully, but eventually you're going to make some steady progress. You may never reach the productivity that you reach that was shown in the other example, where you're just getting things done quickly, but you are going to reach a period where you're maintaining a steady state of productivity. And organizing is very hard, but it is very worth it in the long run. This is something that you'll be working on for the entire life cycle of an application, right up until it is decommissioned. Your organization practices may change over time of that life cycle. And this is something that you'll be working on throughout your entire career as a programmer. If you want to learn more about this, there's just a really quick run through of this. There's some really good resources online. So here's some videos. You can see each topic can run for over an hour. Chris Powers does a really good introduction to this in JavaScript. So his problems are slightly different to what we did today. And he focuses more on JavaScript, and his solutions are to do with using objects and classes in JavaScript to solve the problems. And just to finish up, as we said, that we often might not apply these because we limit ourselves in thinking that these are object orientation design principles. So what I like to say is these are guiding design principles. So as we saw at the start, that really a class is just a group of functions. And when you organize your functions as well, you organize them nice, the source files that they're in kind of start to look like classes as well. So what we should say is maybe just applying the guiding design principles to the web. And that's it. Thank you.
Awesome. Thank you very much, Jordan. Very, very interesting talk. Yeah, and again, any questions, fire in the chat. You can unmute yourself. There's a couple were sent through. You had touched on like the file structure and how you can like drive these principles. Like, is this something like you've seen in practice with larger projects, and even that as well? Like, some people think about like the file name itself and how you can like name things. You could maybe do like .interface, .factory, .whatever.
This will be, I think nowadays with more microservices, it's less of an obvious problem to people. But if you're still working in a monolith, it's very important for good file structure. And sometimes when you go deeper into these principles, might even pose the question if microservices are good. So like the Liskov substitution principle, so it might give you to the conclusion that being explicit is better being implicit. So having all your typings or your source files together might be better. So then it becomes extra important. Sorry, what was the other part of the question?
Oh, like, and then like has like file naming come into play as well? So like, the folder structure kind of defines a pattern, but like potentially with like the name of the files. I'm kind of thinking even in relation to like, if you've seen like the next 13 beta that came out where they were kind of heavily relying on like the name of files to drive what its purpose was.
Yep. Yeah, that's an interesting one because I saw that. And that does bring up the question, is that coupling more to the framework? So we like to build our software to decouple from the framework as much as possible. It's just a tool at the end of the day. Frameworks don't live forever. So that poses an interesting question. But also I'll say that naming things is very hard. That
Yeah.
is, if you can get good at it, you will be a good programmer, I think.
Yeah, someone who can build a good variable namer would be a really good product that would sell a lot. It's a good startup idea. So another question came through is like, you're showing some examples with like TypeScript. Even when I was like looking at examples and you were talking to I like instinctively thought like you were going to talk about like an Angular application when it came to like classes and that kind of stuff. And it's rare to see object oriented stuff in React. Is there influences from like how TypeScript has kind of played a part in like, you know, typing things and the way TypeScript is kind of almost class and orientated focused? Is that bleeding into like the code itself?
I have actually built a React application in TypeScript using object orientation patterns and principles. If you have a weekend to yourself, I would really recommend it. It definitely changes your way. As much as if you do a functional language, it changes the way you think about programming. It's fun, and I would be interested to see if more people would attempt it as well.
Yeah, I've tried it before and I've struggled. And I think that was back in like React 0 point something days. So I'd be interested to see how it works today. And even kind of like looking at some of the things you were showing there, like, you know, the pattern of like how you were rendering components instead of having so many props. And like, I think it's like the render props kind of pattern. It kind of closely almost aligns to how I've visualized like higher order components and like currying, which are kind of functional programming ideas brought into more classical idea. Like, you know, do you see the comparisons and the kind of connection with those things?
Oh yeah, these ideas have been around since the beginning of programming. There's just so much information out there that it's hard to find out a good way to explain it, I guess.
Yeah. Okay. And then like in the last, it perfectly fits in the last one. Like, you know, you're saying about like, you know, the beginners of the web and people don't learn these kind of patterns. Like, you know, what is the kind of the learning curve to kind of get into this mindset where like, you know, we come out of university and we're just taught like jQuery, and then now you're learning about inheritance and composition of classes and this kind of crazy fun patterns.
That is $1 million question. How do you learn this? I think just find a good mentor. Just program a lot, read a lot, watch a lot of videos. Still working on that answer myself.
Oh yeah. Like it's one of those kind of things you get to the stage where like you figured these things out, and then people ask you like, how did you learn all this stuff? And you're like, I don't know. I just kind of stumbled on it.
Very much.
Awesome. That's amazing. Thank you very much. It was very, very interesting talk. Yeah, I'm stealing this idea for a stream of building a fully object-oriented React application, sticking to those patterns, which is really cool.
It's quite fun.
Yeah, there were some patterns like when you had like the interfaces and they looked like traditional classes, the way they were defining the functions and stuff. And like it brings a lot of kind of ideas and things to mind that I was very like, I've been functional focused for so long because React was kind of pushing that idea, but you can achieve better patterns. Yeah, very cool. Very